Let's look at an example using equivalence. Say we have a solution that has 5.3 grams of calcium ions, and we want to know what the equivalence is, how many equivalents are in that same solution. So what I'm going to do here is similar to what I've done before. I'm looking at my units, looking at the information I know and what other relationships I know. And what I know about equivalence is, I can say for calcium, I know that there are 2 equivalents per mole. I know that calcium has a mass of 40.1 grams per mole. And now that can use that information to get from grams to equivalents. And working with equivalents is no different than working with any other relationships. The big thing is that I have to figure out what the equivalent is per mole, and that's going to be based on the charge. So it's 2 plus, so it's 2 equivalents per mole. If it was a 2 minus charged anion, it would also be 2 equivalents per mole. So here I could take my 5.3 grams of my calcium ion. Now I'm going to convert that to moles because I have grams on top here, so I know I need to have grams on the bottom so that I can cancel that out. This gets me to my moles of calcium, so grams cancels with grams. Now if I stopped here, I'd have moles of calcium, but that doesn't get me where I want to be. I've got to know equivalents. So now I have moles in the numerator, I need moles in the denominator, and I know the relationship there is 2 equivalents. So now moles cancels with moles, and what I'm left with for units is actually in equivalents, and I have 5.3 times 2 divided by 40.1, and so I have 0.26 equivalents in this sample. Now if I wanted to, maybe it would ask me about milliequivalents. I could take this one step further. So if it was giving me the grams of calcium and asking me to go to milliequivalents, just to show you can do all of it in one process here, we can start with the same thing that we did before. 2 equivalents is per mole, and then I know that 1 equivalent is equal to 1,000 milliequivalents, because milli means 1,000 no matter whether it's millimeters, milligrams, or milliequivalents, it still means 1,000. And so if I converted that into milliequivalents, I'd end up with 264 milliequivalents. And so I'd have to rewrite that into scientific notation in order to get the correct number of sig figs. And so I'd get 2.6 times 10 to the second milliequivalents. So whenever I see milli, it's no different than anywhere else I've seen it. It still means 1,000th of that base unit.